All right, guys. So we are starting new lessons. I know it's going to kind of be hard to learn Algebra 1 remotely, but we are going to try our hardest. So we are starting Chapter 7. Chapter 7 is all about polynomials. And we've kind of touched on polynomials a little bit, but we are starting 7-1 today. And I'm recording myself so that you can hopefully have a little bit of a better understanding, and I'll attach these, or I'll link these, I should say, to each day of your notes. So watch it, rewatch it until you kind of get the hang of these, since I can't, be in a classroom with you. So polynomials are an expression consisting of many terms. So you could have, for example, 5, you could have negative 6x, you could have 4x squared minus 1. The list goes on and on and on. It is built of terms, plus signs, minus signs, the whole ordeal. You've got standard form, which is largest exponent to smallest exponent. The notes I'm attaching are going to be straight from the lady who created the packet instead of mine, mainly because I know my handwriting's small and hard to read sometimes, and hers is considerably larger. She has that they have to be in alphabetical order. That is not a math rule that any of us have ever heard about, so we're going to ignore that. We're just focusing on largest exponent to smallest exponent. So diving right in, write each polynomial in standard form. So number 1, if you look at this, you've got 3x plus 1 plus 2x. Well, which of those exponents is the largest? This. So you're going to put that first. So 2x squared is going to come first. It's a positive. Then move down the line. From 2, it goes to an exponent of 1, which gives you that 3x. That 3x is positive, so plus 3x. And then that plus 1 is all that's left over. And that is all you do. Largest to smallest. So number 2, if you're looking at this one, largest exponent, you've got a k squared, no k, a singular k, and a k cubed. That k cubed is your largest. So that 7x cubed is 7k cubed. 7k cubed is going to go out front. You go to your next smallest, the 2. That's a positive as well. So plus k squared. You've got your singleton k, which is a negative. And then you've got that 64 that has absolutely no variable attached to it. So standard form is just quite literally reorganizing the order of your puzzle. Have you done those slide puzzles when you were a kid where you had to slide them up and out to make a picture, and it was normally in a square? Well, that's what you're doing. You're doing a slide puzzle. Number 3, your largest exponent is already out front, so that's kind of nice. You've got that w cubed. Moving on down the line, we go to the squared, which is right next, which is looking good. But then we go 28 and then a negative w. That negative w has to come before the 28, so minus w plus 28. All right, number 4, you've got 24 minus n cubed plus n. What's your largest exponent? It's that n cubed, but you've got to watch it because if you look at it, that's got a negative. So you're going to put a negative n cubed. That takes that out. Well, you don't have an n squared, so that can't be in there, but you've got an n, so plus n, and then that 24 is positive, so plus 24. I think we are going to go ahead and skip 5 and 6. We're not going to worry about those kind of equations. I'd rather you focus on single variables, largest to smallest, rather than doubles. Degree. Degree is your highest exponent. It's a way of classifying your polynomial. Which, moving on, the next section is classifying polynomials. So polynomials are classified by their degree and their number of terms. So this first column, I don't know if you can read that. It says a degree. If your degree is a 0, that means a constant. That, for example, would be like a 5 or a negative 3. Something that doesn't have a variable, your degree is going to be 0. Linear, which means you have an exponent of 1. So if you're moving along, that would be like 5x or negative 3y. Something that does not have a visible exponent, because remember, if you can't see it, it's automatically a 1. An exponent of 2 is quadratic. So 5x squared, or for example, negative 3y squared. Cubic is, to the third, 5x cubed, or negative 3y cubed. And quartic is 4, 5x to the 4th, or negative 3y to the 4th. Past that, there are no cutesy little names. You've got to say degree is 5, degree is 6, so on and so forth. I mean, I'm sure they could make up like quintic, and I don't even know what they would use for 6, but then you've got number of terms. Again, that's kind of hard to see. I should have printed out a new packet before I started this. If you have one singular term, it's called a monomial. Now, when I say one singular term, I mean you've got one thing, no plus signs, no minus signs. So you could have, for example, 2xy squared. That's fine because there are no plus signs and minus signs. It is one singular term. Then you've got two terms, which are binomials. So that could be super simple, 2x plus 1. It could be 3x plus 5y. It just has to have either a plus sign or a minus sign in between your terms. Trinomials have 3 terms, so that could be 2x squared plus 3x minus 6. Oops, sorry. 1, 2, 3. You still have to have plus signs and minus signs separating. Plus signs or minus signs, I should say. And then lastly, if you have more than 3 terms, there's no cutesy name. It's just a generic polynomial. So, next set of examples. Classify each polynomial by the degree and number of terms. So if you're looking at number 7, that's 6. 6 has no variable, which automatically makes it a constant. And then from there's no plus signs or minus signs, which makes it a monomial. Number 8, you've got, well, that's wrong. That's kind of funny. Ignore that. That's not right. I really don't know where that came from. You've got negative 2x. Well, that x has an exponent of 1 that you can't see, right? Which means it's linear. Now, how many terms do you have? You have one singular term there. There's no plus signs or minus signs. So it's linear and it is a monomial. Oops, I need to get my camera straightened out here. Number 9. Well, now you've got 2 terms, so you have to figure out which of those has your highest exponent. Well, this is the only one that's got a variable. That exponent is a 1, which means, again, we're dealing with a linear function. So linear, and then it's got 2 terms separated by a plus sign, which makes it a binomial. Number 10, look for your highest exponent. You've got 2. 2's the highest. 2's are quadratics. And then it's got 1, 2, 3 separate terms, which makes it a trinomial. Number 4, look at your highest exponent. That's a 3. So 3's are cubics. And then how many terms does it have? 1, 2. 2 terms is a binomial. And lastly, number 12. Well, not lastly, we got to hold back, but we'll get there. Your highest exponent is that 4, which is where your quartic comes from. And then you've got 1, 2, 3, 4 separate terms, which makes it a polynomial. And it doesn't matter which order you wrote these in. If you notice, I started by going degree, then number of terms, and then down here I went number of terms and then degree. It would be easier for you if you stuck to a preferred method, but it's not detrimental if you don't do that. Onto the back. All right. So this is the fun stuff. This is adding and subtracting polynomials. You have to add or subtract them by using like terms. There are multiple different methods of how you can do this. Let's see. I do not have enough room. Let's find some paper that I have not already scribbled all over. That'll work. It's got a recipe on the back. Whoa, sorry. Almost dropped the phone. All right, so I'm gonna take this example and I'm gonna rework it for you over here on a separate sheet of paper, and that way you can kind of see what I'm doing. So that example was 11x minus x squared plus 13 plus 2x squared minus 23 minus 5x. Oh, that would help if I had my camera on there. You are adding these. I've seen multiple different ways to do this, and I'm going to show you the 2 favorites that I've seen. Favorite way number 1. reorganize into standard form. So this guy in standard form, which is your highest exponent? Well, that x squared is your highest. So to reorganize that, it's going to become negative x squared plus 11x plus 13. And then over here, it is almost in standard form, but these two are out of order. So rewrite that. 2x squared minus 20. No, I just tried to rewrite it. Minus 5x minus 23. Now, it goes 2, 1, none, 2, 1, none. It's in the same order, and since we're adding, what I'm going to do is I'm going to set it up like an old school addition problem, where you write 1 on top of the other. Put a big addition sign right there and go ahead and add. So what's negative 1 plus 2? That's 1. Am I allowed to put that 1 there if I want to? Yes. Do I have to? No. What's 11 plus negative 5? Well, that's 6. What's 13 plus negative 23? That's a negative 10. So that's one way you can do it. If you have 3 separate terms at the beginning, you should most likely have 3 separate terms at the end, by the way. Another way to do it, take that same problem down here, is combining like terms as you see them. So it's a lot of parentheses. If I have that 11x, well, where's my singular x over here? It's that negative 5. Plus, and then I've got that negative x squared, plus, where's my x squared up here? It's a 2x. And then plus my last term is a 13, plus that negative 23. So then you go ahead and add everything kind of separately here, which gives you, 6x plus x squared minus 10. Is that in standard form? No, it is not. So you have to change it into standard form. Again, largest exponent to smallest, x squared plus 6x minus 10. If you notice, we got the same answer both ways. So it is completely personal preference how you want to do it. So coming back over here, I think I'm gonna want another sheet of paper. Give me a second. Paper, 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 paper. If I were a blank sheet of paper, where would I be? That one. All right, the subtraction problems are kind of nastier. This example problem, again, I'm writing it out on a separate sheet right now, and that way we can kind of talk about it. And I'm gonna do the lineup method on this just because I tend to think lining them up is a lot easier. So first things first, you need standard form. The nice thing is this one is already in standard form, largest exponent to smallest exponent. So 4x squared plus 5x, I don't need to do anything with that. And you are subtracting this one, that's your largest term, 3x squared plus 7x plus 1. Line them up, 4x squared plus 5x, and then you've got 3x squared plus 7x plus 1. And you are subtracting these, and you need to remember that all the way out. Subtraction is a lot harder to remember that you're consistently doing that all the way through a problem. Do you notice how there's a blank spot right here, and we've got a number below it? If you've got a blank in a problem, fill it in with a 0. So what's 4 minus 3? 1. So x squared. Do I need the 1? Nope. Can I put it in there if it makes me feel better? Yes. Next, 5 minus 7 is a negative 2. And 0 minus 1 is a negative 1. And that's probably the trickiest part, is remembering that that 0 is in there. So, let's go back over here. So these first couple of problems, like 13 is super simple. If you can see, all right, I've got 2 terms here and I've got 2 terms here. I'm adding them. So what's 1 plus 4? Well, it's 5. What is 5 plus a negative 7? Negative 2. That's all you have to do. If not, you're going to want to line it up. X plus 5, 4x minus 7. Go ahead and add it together and you get 5x minus 2. You get the same answer. Number 14, already in standard form. So again, if you want, you can just arc it. You can say, all right, I've got a k squared and a k squared. Well, k squared plus k squared gives me 2k squared. I've got a negative 4k plus 9k. Well, 9 minus 4 is 5. And then lastly, I've got 7 minus 3. 7 minus 3, that's 4. And be done. But if you need to, go ahead and line it up. K squared minus 4k plus 7. K squared plus 9k minus 3. Do the addition. You still get 2k squared plus 5k plus 4. Number 15. Number 15 is in standard form, but you're missing some things. So if you notice, you've got a w cubed here. There is no corresponding w cubed over here. So if we were to line this one up, we would have, w cubed minus 2w squared minus 5. And then I would have 3w squared minus 11. And when I added those together, I would fill in that 0 right there. I have to box in my answer. So w cubed plus nothing is just w cubed. Negative 2 plus 3 is 1. And negative 5 plus a negative 11 is a negative 16. Still getting the same answer. Number 16. 16 may throw you just simply because it's got two separate variables. But you treat it the same way that we've been treating everything else. Just line everything up. 9x minus 5y over, you want to make sure you've got x's over x's, y's over y. So this goes 3x plus 2y minus 7. I'm adding, well, you've got 9x over 3x, which gives you, 12. You've got negative 5 plus 2, which is a negative 3. And then you've got 0 plus a negative 7, which gives you negative 7. Whoops. There we go. Number 17. Oh, I already scribbled half of 17 out for you. I'm sorry. Not in standard form, which may throw you, may not. If we go ahead and line this one up, I'm going to reorder this one as I go. That's going to be negative p squared plus 5p plus 8 over p squared minus 4p minus 15. We are still doing addition. So negative 1 plus 1, those end up canceling. 5 plus negative 4 is just 1, and 8 plus a negative 15 is negative 7. Oh, booger, I have crossed out my answer again. Number 18. Again with the adding, man. So that first one is already in standard form. 6a squared minus 5a. Your second one, however, is not in standard form. I did not leave myself enough room for that. You've got 5a cubed. If you notice, you don't have an a squared anywhere in here. So we're going to put a plus 0 minus 5a plus, oh, booger. Scratch that. We're gonna rework this one over on the side because I was not paying close enough attention. All right, that's a 6a squared minus 5a, and then that's a plus a minus 5a plus 3a cubed. Sometimes I worry about my brain. If you look at this, those are like terms. We can go ahead and simplify that right off the bat. That would make our lives a lot easier. So that's 1 minus 5. 1 minus 5 is negative 4. Now let's go ahead and line everything up. So 6a squared minus 5a, and then we've got 3a cubed plus 0 minus 4a. And we are adding these together. So nothing plus 3a cubed is 3a cubed. 6a squared plus nothing is 6a squared. And a negative 5a plus a negative 4a is a negative 9a. Hey, that looks a lot prettier. All right, 19. 19 is our first subtraction problem. Woohoo! So go back. Is it in standard form? Yes, it is. Both of these are in standard form. So if you are capable of saying, all right, I've got 1 minus 3 and get a negative 2. And then 17 minus 5 and get a negative 12. Be my positive 12. Good Lord, positive 12. If you're capable of doing that, be my guest. If not, go ahead and write it out. X squared plus 17x, 3x squared plus 5x, and then make sure you're subtracting between both and you'll get the same answer, guys. 20, you've got the two different variables again. So 5r minus 2s. I want to make sure I've got an r over an r. If you can hear my dog whining, I'm terribly sorry. My child's outside on the four-wheeler and she's a little unhappy that she's not out there. It's a horrible, horrible life for our dogs. But, you know, either way you do these, you're going to get the same answer, no matter how you group them. Ooh, 21's fun. We're doing 21. So 21, if I line this up, 4c minus 11, and then I've got 4c plus 11, and I'm subtracting these, well, 4c minus 4c, that cancels. But I've got, Lou, stop. I've got negative 11 minus 11. That's where the negative 22 comes from. And that's why you don't have anything else. You just have a negative 22. Nice, pretty piece of cake. 22, already in standard form for you, both of them. So line them up. 3m squared plus 7m minus 1. M squared plus 2m minus 5. Go ahead and subtract. 3 minus 1 is 2. 7 minus 2 is 5. Negative 1 minus negative 5 is a positive 4. Watch those double negatives. Some of you are still struggling with that. Make sure you pay attention. We had one up here and I didn't even catch that. It's negative 2 minus negative 11. If you are subtracting a negative, it turns to a positive. So that's negative 2 plus 11. That's where the positive 9 comes from. Make sure you're watching that. This is a really long video. I'm sorry, guys. I'll break the next one into 2 different parts instead of rambling for 20 odd minutes. 23, not in standard form, so I'm going to adjust them as I go. Negative v squared plus 7v plus 14 over v squared plus 8v plus 15. And then we are subtracting. Negative 1 minus 1 is a negative 2, v squared. 7 minus 8 is a negative v, and 14 minus 15 is a negative 1. And 24. X's over X's. Whoa, Y's over Y's. I don't know where I thought that 2 came from. And then, if I want X's over X's and Y's over Y's, then I have to readjust this one. So I'm going to have to put 5x plus 2y minus 13. Subtracting, and what do I fill in right here? A 0. So 5 minus 8 minus 5, good Lord, is a 3. Negative 3 minus 2 is a negative 5. And then if you are taking 0 minus negative 13, that's that double negative, that gives us a positive 13. So these aren't particularly complicated. They just, take a little bit of brain power. And you've got brain power. 25 tells you to find the sum. Well, sum is addition. Y'all should know sum is addition. So you are adding these two together. If we come over here and we line it up, that would be 8p squared. Minus 2p plus 15. And then that would be over negative 2p squared. And then if you look at this, that's another one of those. You've got negative 1 and 11, and that gives you 10. So plus 10. You've got nothing to fill in right here. So 8 minus 2, because we are adding these. Add. 8 minus 2 is 6p squared. Negative 2 plus nothing is negative 2. And 15 plus 10 is 25. Where on earth did that 3 come from on my paper? Sometimes I worry myself. So that should be your final answer for number 24. 25. We're talking about 25. Good gravy, Miss Maybe. All right, last one, boys and girls. So you are subtracting this expression from this expression, which means this is going to be your expression on top if we line it up. So 26, we're going to put w cubed plus 6w squared. That doesn't even look like a cubed. There we go. And I'm going to leave a space, minus 2. Oh, hey, you can even see that. Woo, there we go. Over 2w squared minus 5w plus 10. I left a blank here because you have no singular w with a 1 like we do on the bottom. And I left a blank here because I realized you don't have a cubed in this expression. This is one of your trickier problems if you've not caught on. And you are doing a subtraction. So w cubed minus nothing is w cubed. 6 minus 2 is 4. Nothing minus negative 5. That's one of those double negatives you've got to watch for, is a positive 5w. And then negative 2 minus 10 is a negative 12. And that's how you do that. Oh, good Lord, my camera. And that's all you do. So if you have any questions, comments, or concerns, let me know, and I'll try to walk you through it a little bit better if you need me to, okay?